Good morning, everybody. My name is Jonathan Rushton. I'm the Director of the Global World of Animal Diseases Programme, and I want to welcome you today to the GBADs DECIDE Webinar number 9, Tools for Decision Making, Turning Data into Actionable Information. We have a really great programme for you today. We're going to start off by presentations from João and Afonso and Sara Babo Martins on the GBADs work with regards to antimicrobial use, antimicrobial resistance, and the dashboard that they've been developing. Sara is an honorary research fellow at the Roslin Institute, University of Edinburgh. She works very heavily on One Health and particularly identifying and measuring its value. And in recent years, her research has concentrated on antimicrobial resistance and its impact on livestock. Sara holds a master's and a PhD from the Royal Veterinary College in the University of London. They're going to present together, so I'm going to introduce João as well. João is also an honorary research fellow at the Roslin Institute. He's a vet by training and specialises in epidemiology and animal health economics. After he completed his PhD, he has a broad interest in animal health and welfare, with a recent focus on assessing the burden of antimicrobial resistance in livestock species. The work that João and Sara are going to present today has been funded by various sources, so a H2020 Project Avant has been involved in this, also Fleming Fund from the UK government, and Sara and João, I'm going to hand it back to you to start, and there'll be time for some questions at the end of their presentation. So Sara, I'll let you begin. Thank you.
Thank you, Jonathan, for the lovely presentation. Just want to make sure, can you see my screen?
Yes, we can.
Yes. Okay. So I'm going to go ahead and just say, everybody, good morning, and thank you so much to Marguerite and the DECIDE project for the invitation to be here today. It's a great pleasure. So in this presentation, João and I will share with you how we've looked into the burden of AMR and AMU in livestock through the GBADs approach. We are going to hopefully also show you how we try to turn that information into decision-making instruments through our dashboard. So I mentioned I'll be sharing this presentation with João. Afonso is going to take over the second half of the slide deck, but I also want to acknowledge a big range of colleagues that have contributed to this work and made this work possible with time and thoughtful conversations and expertise. Jonathan mentioned this, we had financial support from the Fleming Fund, so we are also gratefully acknowledge that, and from WOHA. And I would like to start to set the background for the presentation by bringing a little bit the topic of our seminar today and how information can generate decisions and impactful information. And hopefully, we always want to have the cycle straightforward from data to data tools, connecting the dots to generating information, decisions, and impact. But many times in AMR, and I suspect in other diseases as well, we see a little bit the reverse. We see that decisions are generating actually information, and then we have the need for data tools, and then maybe we start to measure impacts. Now, there are several reasons for that, particularly on the AMR side, and they're all a little bit linked to the complexity of AMR. It starts by the fact that there are only in livestock dozens of backdrop combinations of interest, each with its own dynamics and challenges. AMR is not a single condition, it's actually an underlying process for disease. And so it cuts across all these backdrop combinations and livestock species. Then still linked to its complexity and complicating things is the fact that we all know that AMR is truly an urgent global health problem. It has impacts spanning across a range of sectors, and there is a sense of a real need to tackle the problem. Then we know that the problem actually has quite a complex epidemiology. It has trade-offs, and those trade-offs are across all range of sectors, and it's truly, really One Health. If there is a flagship issue for One Health, probably AMR is the one. And then finally, we have also contributing to this potentially the fact that we have short funding and investment cycles, which make it difficult to plan long-term data collection tools, and really sustainable solutions for this. So we end up sometimes in this kind of reverted cycle, but not always bad. Sometimes this reverse cycle can actually be catalytic, and those decisions create the demand actually for tools. And then hopefully, once we have those tools, we can enter again into a cycle where we want to be, which is data-driven decisions. So where does economic data can contribute to all of this? When we think about economic information and then economic tools that can inform actionable information, first we can think that if we generate burden of AMR information, we can start to generate estimates of impact, and that is really important, critical actually, to justify budgets, justify prioritization, and even scientific funding proposals. So that's already quite useful for decision making. Then in terms of cost of interventions, we can start to see if what we're intending to do, planning to do, is actually feasible, how much will it cost, and take some budgeting decisions around that, and then build upon this and try to actually also assess cost effectiveness and cost benefit of interventions, so we can start to compare different alternatives of interventions, of decisions, once against the other, and then actually choose the highest value intervention. Now, this information is also quite helpful for policy making and to drive awareness for problems. And in the case of AMR, as the economic evidence on its impact is also mounting, and we know more and more, it's also been the case that it has come up to the highest level of the political agenda in terms of global health. So where are we in terms of economic tools in the realm of human health, in the realm of AMR, particularly in human health? Now, we have potentially a stronger portfolio of resistance and usage tool. This is for human health. There's international tools, there's a range of regional tools and national tools as well. There is an international costing tool, particularly for the national action plans. And there's a ever-growing body of evidence, I mentioned this already, on how AMR impacts human health. From the O'Neill report right at the year of 2016, almost 10 years ago, to the Eco-AMR series that was launched last year, that continue to assess both in terms of economic impact and also burden assessments produced by the AHME. On the animal health side, we also have some epidemiological and usage tools at the international level, more and more also at the national and regional level. We have also a growing body of evidence on the economic impact, although still lagging behind the human health. But we don't have any tools actually that help us assess both impact from livestock, intervention costs, what gives us the best return on that investment, or how to prioritize that spending. So that's a little bit the evidence gap that we know it exists and where our project sits. We wanted to start to fill this gap by estimating the burden of AMR and ANU in livestock within the broader context of losses. So that's the GBADs approach, and produce estimates for those burden in selected case studies. So test our methodology, see how they behave, and then dashboard those results to be able to show them to stakeholders and start stakeholders for interact with those results in order to eventually make decisions. This is a project that ran from 2022 to 2025. The starting point was a conceptual framework which allowed us, and I invite you to, if you're interested in knowing more, to follow the QR code that's below on the slides. The conceptual framework really helped us to understand how AMR creates pathways for losses and how those pathways for losses can go into the one metric of GBADs, which is the animal health loss envelope. This is an envelope that has within it losses due to all causes, including infectious diseases, but also other causes, as you can see here. And AMR will naturally sit within this box, the wider box of burden of infectious diseases. Now, this can be losses because there's mortality, there's production losses, and there's healthcare expenditure there. And AMU starts to sit here every time we use antimicrobials to control a disease. We're already having a pathway for loss generated there. So AMR will sit within here by generating losses which are attributable directly to resistant pathogens that can be due to mortality, extra mortality that we wouldn't see in a susceptible infection, for example, or extra productivity losses because we have, for example, lower yields on our animals, or we have, for some reason, premature culling. Or we could have also extra healthcare expenditure, which we can attribute to AMR pathogens because of that resistance. For example, we can have diet interventions to manage those infections, or we can have extra diagnostic workup or veterinary time. Now, there's a part of this diagram, which is the One Health burden. We don't, so far in our work, directly address the One Health burden, but we leave it there as a sort of compass for us at some point that would become the ultimate goal, to be able actually to link up the two burdens. And I'll stop here and hand over the screen, the presentation, to you, João.
Good morning, everyone. I hope you can all hear me, and apologies in advance for the lack of professionalism, but I'm sitting at the airport trying to give this second part of the seminar. Sara, I've just requested control. Can you confirm that I'm all good to go?
Yes, you're good to go.
Okay. Apologies, that will probably be a little bit of a lag, but anyways, welcome everyone. And thank you, Sara, for providing the context to the dashboard that I'm about to present. I will not be able to provide you a in-depth walkthrough the dashboards just because of time constraints, but do come back to us if you have any questions or if you want further information on. Oh, okay. So on the top right-hand corner, you'll have the QR code that will direct you to the dashboards. You also have the link beneath the screenshot. So the dashboard has three main tabs. The first one is about the user guide and references that provide the scientific support and the rationale for the work that we have conducted. We then have a tab on expenditure with antimicrobial usage, and lastly, the country case studies. Now, the expenditure with antimicrobial usage draws from the phase 1 of this work that we have conducted, where we have made use of data from different sources, and we actually challenged those sources in terms of biomass predictions, in terms of volumes of antimicrobials, and we also try to use that information to assess the expenditure with antimicrobial usage based on literature review on the prices of antimicrobials, where there was information to fill in that data. For specific regions where there wasn't, we had to do some extrapolation. So all of this will be clearly laid out in the dashboards. We've also made use of the data available on resistance to display it and to create a drug-resistant index. Again, further information on how we made this drug-resistant index is available on our user guide and references. And then we have the country case studies. Now, the country case studies at this point, we only have two, the Danish case study and Ethiopian case study. I will explain both of these case studies in more detail in the next few slides. But just to let you know that the user at this point has the ability to use the drop-down menus to select the country, the species, and the disease in question. And also on your left-hand corner, the user can select the by which data is displayed. So you can see that the user can observe the absolute burden. You can also look at the relative burden or the burden per biomass, and you can see it as an overall picture or also by production stage. Now, moving on, and I would like to call your attention to the case studies. Apologies once again, I won't be able to provide you all the details about the methods that we have used to conduct the analysis. Come back to us if you have any further questions. And we hope that in the coming future, we will have publications outlining clearly the methods used to produce these figures. As Sara was saying, AMR is a complex problem. It has a myriad of bug-drug combinations that you might want to select to start your assessment. So, but we need to define an entry point. And for our Danish case study, our entry point was resistance in post-weaning diarrhea in piglets in 2022. So after looking into the literature and also consulting with experts, we have considered nursery and breeding stages to be affected by resistance in post-weaning diarrhea in pig production. So we've developed a dynamic population model to assess the production losses by considering that some of the parameters would be affected by the presence of resistance within these systems. And we've also considered expenditure, taking into account the surplus of antimicrobials used to fight off the resistant cases or to deal with resistant cases, and also some other inputs based on expert opinion to build up our burden of resistance in post-weaning diarrhea in Danish pigs in 2022. So in our dashboards, you will be able to see this graphic. So the user has the ability to understand not just the entire animal health loss envelope as Sara was describing. So it is one of the fundamental steps of the GBADs approach. You need to define the envelope of losses, and then to appreciate what is the relative contribution of resistance in post-weaning diarrhea within the wider view of the animal health loss envelope. So we can see that antimicrobial resistance in post-weaning diarrhea would contribute to approximately 2.7% of the animal health loss envelope. And you can see the breakdown according to production losses and health expenditure, where you can perceive that production losses are the major contributor to the burden associated with this health problem. You can also see it according to production stage. Here we can see that nursery, for example, it's the production stage capturing the majority of the burden. We can also see the burden according to kilogram of biomass, and appreciate the same information displayed in the first graphic of this case study, but displayed in a relative terms. So here you can appreciate that health expenditure only contributes with 0.4% to the total burden. So our second case study was about cattle in Ethiopia, or it was on cattle in Ethiopia, and our entry point was resistance in clinical mastitis. 3 production systems were considered for this case study: pastoral, crop livestock mixed systems, and specialized systems. So these would be considered the intensive production dairy systems. And again, we have our dynamic population system capturing the production losses, and we have the expenditure assessed via a data collection exercise conducted with a colleague of ours that capture the expenditure with antimicrobials for livestock production, and then we applied a certain of assumptions to estimate what would be the expenditure for dealing with antimicrobial resistance within clinical mastitis for this production species. And we used both of these to come up with a burden of resistance in clinical mastitis, as we also had some data available on the indirect costs, for example, antimicrobial resistance stewardship programs. We also considered this to be part of the burden of resistance in clinical mastitis in Ethiopia. So here again we have a display of the total animal health loss envelope, which sums up to approximately $50 billion US, and resistance to in clinical mastitis accounts to 4.4% of that sum. Again, we can see the burden across the different production systems. Here, interestingly, we can see that the crop livestock mixed systems is the production system most affected by all burdens, and also for antimicrobial resistance in clinical mastitis. It is, as you can see by by being the highest bar. But if we now see the burden for according to kilogram of biomass, you can see that there is a shift. Now, with the first slide, we could obviously, if you knew the distribution of the cattle across the different production systems, you would know that the majority of cattle is farmed in crop livestock mixed systems. And that's the reason why the burden is so high. But then when you shift this for kilogram of burden per kilogram of biomass, you'll see that there's a shift. This is an interesting insight to understand better the burden within each system and how to better prioritize our interventions. And lastly, the same information as before, but again, represented in relative terms. And we can see that the expenditure here and even indirect costs are just a fraction of the burden due to resistance in clinical mastitis. Now, for the Ethiopian case study, we conducted also an exercise to convert the production losses to meals. And in 2022, there were roughly 481 million liters of milk lost due to resistance in clinical mastitis. They were unevenly distributed across the different production systems, but if we were able to avert those losses, we'd be able to feed 31 million people just in terms of obviously milk meals, but to feed 31 million people. And we thought, even though this is not dashboard, we thought it would be an interesting outcome of the work that we did. I think this is over to you now, Sara. Give up control.
Thanks, João. So I'll wrap up just by saying that we presented this results to our stakeholders in countries. We held 2 stakeholder consultations, one in Ethiopia and one in Denmark, which allowed us to get some feedback on the preliminary results we had. We at some points adjusted our methods. We also had feedback of how this information could be better used for decision making and what the dashboard could show that would be really useful for people directly affected by this information. My concluding remarks, or our concluding remarks, would be that it's doable to look into AMR in an economic perspective, particularly if we start small. You can see here we had a limited scope, that's by design, but these assessments are possible. They can generate some evidence that can be interesting for decision making. As João showed, we had some insights that were interesting to see, even though the complexity of AMR can often feel very daunting. But there's also a big issue underlying here, which is the availability of data. This is something we'd really like to address in future work. We would like to continue to expand this work by enhancing data collection, for example, by the generation of a community of practice, and also to expand and refine analysis in some case studies, particularly to expand, and this is considering also our feedback from stakeholders in country, to extend to look at how interventions behave, particularly both in terms of ANU stewardship and AMR mitigations. And we'll conclude here. Jonathan, over to you.
João, Sara, thanks so much for a really nice presentation. If you have a question, either put it in the chat, the Q&A, or raise your hand and we'll come to you. We've got about 5 minutes for questions, and there is a question already in the Q&A, which is, how do you avoid double counting when AMR both prolongs disease and drives repeated treatments that already show up as a basic pathogen loss? So Sara, João, I'll let you decide who's going to tackle that question first.
Okay, I'll take that one.
Okay.
So it's about ensuring that you're classifying the cases correctly. So for those that are not deemed as resistant, they will have their own specificity in terms of the expenditure and production losses. And for those that are resistant, you will have a surplus regarding expenditure and production losses because of that prolonged disease. But as I understand it, and the approach that we've taken, it's about classifying correctly the cases for both resistant and non-resistant cases. But Sara, if you want to...
Yeah, no, just to complement, it's a great question, and it's a concern we also have, kind of not to double account effects, and it's something really to have in mind. So it is a great question, and one that we also had to tackle, potentially not perfectly yet, but as we continue to develop this work, also keep it close to our hearts and in mind.
Thanks, Sara. João, we've got a question, I think, from John Berezowski, but John, I can't see how I can actually allow you to speak. Margarita, can you unmute John, please?
Yes, I just gave John possibility to speak. Hi, John.
John, please go ahead.
Can you see me too? I can't see myself.
No,
okay.
No.
You don't need to see me anyway.
We know what you look like.
Yes, you do. I'll take you back to your first slide about the model of how we plan surveillance. And usually we start with a problem that we need to do something about and have an action in place and then go backwards. We're all looking for information about the burden of antimicrobial resistance. So this information, I think, is going to be useful. But what are the plans for sustainability now? Because if I'm thinking about what we're doing in Scotland, there's this problem of antimicrobial resistance. But how would I justify doing this spending money, Scottish public money to do this. I still struggle to make those connections in my head for antimicrobial resistance. So what are your thoughts? I think there's something here, but I can't see it.
Sarah, I'm going to go to you first.
Hi, John. Great question.
Hi, Sarah.
I think, well, plans for sustainability. I think what we started to see, John, is that we know very little about the impact of AMR actually in livestock. And yet we have quite a lot of interventions, or there's a drive for quite a lot of interventions in livestock. Doesn't mean that's wrong. It's not, it's right. But we need to be able to show that how those interventions are impacting. Are they being successful? We will not know if they're being successful, not for our livestock and not for our environment and human health, if we don't actually have a baseline to kind of see them against something. So our burden assessments, to kind of what the human health is doing as well, allow us to create that kind of base, that it's to benchmark really. We know what's going on currently. For example, for Denmark, it was really useful to see currently with so much effort going into antimicrobial resistance mitigation. We are able to kind of now have a baseline to which we can, if you shift interventions, if you start to do something else, kind of how is that going to change? And then you can start to do cost effectiveness, cost benefit analysis, which also is very helpful evidence when you're planning things for AMR particularly. Not sure, John, if that starts to address your question.
It does. And actually, my other comment would be that we're thinking now more and more about with surveillance, for disease surveillance, of tying surveillance with risk assessments, living risk assessments and things like that. So I'm wondering if that wouldn't be a way of, because we already collect surveillance data, whether we can use your models and your approach with that surveillance data to have a country-specific tool to help us make those decisions. Okay, I'll stop there. Thank you, Sarah.
Yeah, I'd just add to this, and I'm sure João probably would want to make a comment. I can see Hedin has come online as well. So, John, I think one of the things that Sarah and João's work has sort of highlighted, it's not just the total, but it's also the relative amount of burden that we're looking at in this situation. But also João has quite nicely highlighted that it's not every system that's affected in the same way, or indeed every population group within a similar system that's affected in the same way. So it highlights where we perhaps need to focus and where we need to focus new technologies. And I'd also say I've just been sitting in a meeting here in Scotland where they've been talking about impact of research. Well, if you don't start collecting data, then how do we actually show that we're having impact in terms of overall outcomes and what we're trying to achieve? João, sorry, I'm talking, but did you want to add anything before you have to leave for your flight?
No, I'm happy with what everyone has said. We have little time, so no point duplicating effort.
But John, I'd sort of second the need to think about how do we scale this up. Sarah, João, I know this is something that's very close to your hearts in terms of how we move things forward. Suggestions for collaborations with us about this would be really welcome. I think what Sara and João have highlighted is really important, kind of data gathering, systematic approach, and you can experiment with the dashboard that Sara and João have talked about. Please have a look at it and come back to us with any ideas. Any closing remarks from Sara or João before I pass on to the Cattle Barometer work?
That's all from our side. Thank you, Jonathan.
Well, thank you so much for both of you, and João particularly for managing to combine your travel with doing the seminar. That's much appreciated. Okay.
Thank you for taking me like this.
Yeah. Okay. We're going to move on to the next part of the agenda. So I'm going to introduce Charlotte, and I'm going to get your name wrong. So Charlotte did tell me how to pronounce it, but Charlotte Doidge, I think is how you pronounce it, is an assistant professor of livestock social epidemiology at the University of Nottingham in the UK. She looks at social epidemiology. She was previously a research fellow working on social science work package of the DECIDE project, and her research focuses on farmer and veterinarian decision making and practices related to livestock health, welfare and technology. And Charlotte's going to talk us about the living lab user design aspects of the Cattle Barometer. So without further ado, Charlotte, please go ahead. Thank you.
Thank you. So yeah, as Jonathan just said, I'm going to be talking about the Cattle Living Lab in DECIDE. So for a bit of context, in the Cattle group, we're looking at developing data-driven decision support tools for young stock in particular. So we're specifically looking at things like bovine respiratory disease and gastrointestinal disease. And to develop these tools, we're using a living lab approach. So first of all, what is a living lab? Well, there is no specific definition of what one is, but all living labs should contain these 5 aspects. So they should have user engagement in a co-creative manner. We have multi-stakeholder participation. We use multi-method approaches. And what's important is that we test out our innovation in a real-life setting. In the DECIDE project, we're using a living lab approach called a format living lab. So this type of living lab has these 3 different stages, which each have 3 phases. The first stage is a concept stage, and this is where we focus on looking at the user's needs, and this is before any kind of innovation is developed. Once these needs have been evaluated, we can move to the prototype stage. So this is when our innovation becomes more of a prototype, and here we can explore what the user requirements are for that specific prototype. Then as the tool becomes more developed, we can enter the innovate stage. And this is where it's actually tested out in the real life setting. And here we're focusing on what is the user experience of actually using that tool. But the foundation of the living lab is to understand the user's needs in the concept stage before any innovation is developed. And this is the stage that I'm talking about today. So what are user needs? They relate to overall goals, motivations, and desires, and they are broad and less influenced by trends compared to these technical requirements. So the example that I usually give for the difference between a technical requirement and a need is that if you have a mobile phone, your technical requirement might have been to have a password-protected device, but this development has changed over time, and it might be that you have fingerprint recognition or facial recognition to help you unlock your phone. Whereas whilst there's been this technical development, the overall need for security has remained the same. When we try to identify users' needs, what's really important is that we don't just ask people what they need directly. And this is because it is very difficult for someone to actually answer that question. Also, people try to answer this question by thinking about specific solutions to specific problems. And this doesn't really help us to understand what their broad needs are and can really restrict the creative development process for your innovations. So instead, what you can do is identify their needs through engaging in dialogue with your potential users. And this is by exploring their experiences, goals, and motivations. So this requires a qualitative approach because then the users will provide us with these rich narratives. We did this in DECIDE with farmers by doing focus groups with beef and dairy farmers in 7 different countries. So for these, we use this need finding approach. So this means that we ask them questions about their goals and the future of their farm. And we also ask them about their positives, so what currently works well on their farm, sort of like appreciative inquiry approach. And this is because if we just focus on the potential negatives or what needs to be improved, then again, it goes into these technical requirements and really restricts this creative process of developing innovations. We also did it with some vets in Ireland and the UK. We used a slightly different data collection method of a qualitative survey, but we did the similar need finding approach with similar style questions. So we had all this qualitative data, and how we processed it and coded it to help us understand their needs was to code it using this user-centered needs typology. So this is just, they basically reviewed a lot of psychological literature looking at what people think are the fundamental needs, and they identified that there were 13 different fundamental needs and 52 sub-needs related to innovation design. So we used this to code the data, and these are the 13 different fundamental needs in that paper. And 7 needs were identified for farmers, and this specifically relates to needs for herd health. I'm not going to go through every single need here for the purpose of time, but if you did want to learn more, then we have the published paper in Journal of Dairy Science that you can look at for more information. Similarly, we identified 3 different needs for the vets as well. And one of these was different to the farmers, and that was that vets also wanted impact. And this was because they wanted to influence the way that farmers were using these technologies and tools on their farms, and also just influence animal health and welfare overall. And I also just wanted to note that these psychological needs are very much at the individual level, but when we're developing innovations, we also need to think about the social, ethical, and cultural implications so that we make sure that we are innovating responsibly. So we also did this through various focus group studies as well. The one example here is with Swedish dairy and pig farmers. And some examples of the implications was that the technologies impact workers on the farm differently to the farmers, because the farmers could use them technologies as a kind of surveillance tool to check what the workers were doing. Also, that technologies can impact the human-animal relationship, either by making it maybe stronger because it provides you with more information, but it can also make it weaker because you might not be around the animals so much anymore. So we presented this to the wider group, the people that were developing the technologies and tools, because I'm not doing that myself. And we presented it in like a presentation style, and often we would get comments like this. That farmers didn't know they needed a tractor before they were invented. So why is our tool any different? And that made us realize that perhaps our definition of a need was slightly different to other people's. And this is probably because needs are very abstract concepts. And we as social scientists needed to do better to communicate what these needs were so that the tool developers could really empathize with what the farmers and vets needed. So what we decided to do was a researcher workshop with those that were developing the tools. The first thing we did was a card sorting exercise where we had descriptions of chairs, and each of these chairs actually represented one of the needs we were looking at. And in small groups, the participants just had to match the chair with the need. And I think this really helped everyone to sort of share a common language of what these needs were, so that when we were talking about these needs, we were actually talking about the same sort of thing. Then once we all were on the same page with what the needs were, we moved on to this need empathy mapping exercise. So the first thing we did in the small groups was to develop a user persona of a typical user of a tool. Maybe not the most easiest user to design for, but maybe just like a typical farmer or a vet. So here they created a description of this user to make it seem more real life. And then what we did was we had a lot of pieces of card, and on the piece of the card were real quotes from the focus groups and the survey that we did. And the participants could sort through these quotes and stick on their empathy map what they thought represented their farmer or vet in terms of what that user was doing, saying, thinking, or feeling. And this really helped, I think, because the participants were engaging in the actual empirical data, so learnt more about what the farmers and vets were saying. And this helped to show empathy for these users as well. At the end of this, the participants circled which needs they think reflected that farmer or vet the most. Then the final part of the workshop was to do storyboards, because many of the participants already had preconceived ideas of what concept or tool they wanted to develop. So in the storyboard, they put their user from the empathy map into the story where they were using their potential idea for a tool and just showing the different moments of interaction. And this exercise was useful because it really helped the participants to envision how the users would behave with their idea for a tool, thinking about whether it would meet and satisfy their needs, maybe harm needs as well. So then what happened next is through some discussions, some of the tools did not go ahead because the participants realized that maybe they didn't meet the farmers or vets' needs, or maybe potentially harm some of the needs as well. Some of the tools did go to the next stage, and here we've done things like usability testing and remote usability testing, where they do it online and we video record the users with the tool so we can gather feedback that way. In the next few months, there's also going to be some lunch and learns with vets to gather feedback that way, where they have a discussion at their veterinary practice. The tool developers have started to think about the long-term use after the DECIDE project. And then one of the most developed tools, and the one that we have been doing the usability testing for, is the Cattle Barometer. And that's what Stan's going to talk about next. So I just wanted to say thank you for listening. This Living Lab has had a lot of collaborators, and also the farmers and vets who took part in the studies are really important as well. Thank you.
Thank you, Charlotte. If people have got questions, please put them in the Q&A. We're going to pass on to the next presentation, and then there should be probably about 5 or 10 minutes at the end for any further questions. I want to just quickly introduce Stan Jourquin, who's a postdoctoral researcher at the Faculty of Veterinary Medicine in Ghent in Belgium. Stan is a vet. He looks at bovine internal medicine, which focuses on calf health and the use of quick thoracic ultrasound for pneumonia diagnosis in calves. He also leads a project on Mycoplasma bovis control in Belgium and contributes to the DECIDE project by further developing the Cattle Barometer and practical tools for farmers and veterinarians. Stan, over to you, please. Thank you.
All right, perfect. Thank you. Thank you for the introduction and the opportunity to present our tool here. Also, thanks, Charlotte, for all the help with the design and the survey afterwards of the usability of the tool itself. For today, what I wanted to show is actually, how we ended up building it, and then showing some applications of our tool on its own. We'll just see. So as a really brief introduction, I don't think I need to introduce the topic of bovine respiratory disease too much, but we know, especially in calves, it remains a leading cause for disease, mortality, hampered animal welfare, losses, and antimicrobial use. Still 60 to 70% of the total antimicrobial use in calves is used for BRD, which is a lot despite all of our efforts. And if we want to move towards a more sustainable, preventive, and pathogen-oriented approach, we kind of noticed throughout the years that creating awareness about circulating BRD pathogens is actually one of the most efficient ways to get farmers and veterinarians and producers alike to tackle these diseases. What we also noticed is that there are a lot of labs between countries, but also in countries themselves. There are different labs where different samples are being collected and analyzed, which is a ton of information that sits there and that could be very valuable in showing awareness and maybe even for other tools. But it would be, of course, more valuable if you can combine them on a country level. So we have multiple contributing labs per country, but even on a European level, if multiple countries would actually provide information on this. So in that sense, we came up with the idea of the European Cattle Barometer. What was the main goal? Well, to actually show just descriptives of respiratory pathogens in Europe, to raise the awareness, as I said, but also to address the importance of taking samples. What we notice in our research and in practice is still a lot. Calves and cows suffer from BRD. They get treated and we actually never get an idea what it was. But based on this sustainability clause that we really want to emphasize in our future veterinary practices, we actually want to know which pathogens are causing disease and are circulating at these times. Of course, that's one part. But having that information could also be valued to actually provide early warning for epidemics, but also for purchase. If we know that in certain areas, different pathogens are circulating and at certain time point, this can actually help prevent disease from spreading throughout the country or in between countries. So based on that, it's actually a tool that can in theory be used by both farmers, veterinarians, labs, health institutions, and researchers alike. It's quite broad, but the main goal is actually to provide this descriptive information and see what we end up with. The idea came first from a Flemish lab. They actually are doing it since 2016 already, but this is just PCR data from the Flemish region and not the entire Flemish region even, where they each week they actually give an updated estimate of the prevalence of disease that they get from PCR samples of respiratory samples taken from calves and cattle alike. So based on that, we try to expand. So within the DECIDE project, we had the opportunity to reach out to multiple labs and actually find ways that we can transfer data and get controller agreements to actually see whether we can all combine that and have a more European view on the topic. So from each of the labs that were willing to contribute or where we are still working with, we actually found anonymized data, or we gathered anonymized data from these cattle with the date, the pathogen identification. That's one thing, but also the sample type that was used. For example, was it a lavage of the lungs? Was it a nasal swab? Was it a necropsy? And what test was used? So not only PCR, but also culture and nanopore sequencing were included to actually see what these different combinations were. Of course, also the breed and production type of the calves was gathered. And then we also asked for a proxy of the geolocation. Of course, everything was anonymized. So nothing is traceable back to a single farm. We only see it on a county level. And then, of course, the data, once it was shared, we had to provide a workflow to get it in one single template. That was the hardest part. That was before I was involved in the project, but I'm very thankful for all the work that my colleagues did before I arrived. It's actually making from all these different countries, all these different labs, they send in the data, but that's of course very heterogeneous. Every lab sends it in a different format, and we kind of need to use like a basic template which we can then provide in our structures. So based on that, for each of these labs, a custom script was built to actually finalize the data and get them aggregated by pathogen, diagnostic test, health, and then sampling month. We chose to do it on a monthly level because, of course, in contrast to human medicine, it is a bit more difficult to get consistent sample rates in veterinary medicine. As I said before, because we still have a long way to go in improving our sampling techniques throughout the countries. After that was all gathered and anonymized, through Tableau, there was actually a visualization process where we created an online dashboard that's ready up and available now. And that's now online, where you can actually click around and select different pathogens and other sample types and stuff. This is what it looks like. So overall, this is just a screenshot I took from the website. You can see that the periods that's being included here is from 2016 to 2024. It's a bit of an older screenshot. We have recently updated our data sets to include 2025 as well. As you can see, the countries that are currently contributing are Ireland, Belgium, the Netherlands, and France, and it's based on country level. What do we have? It's not only like historical trends, which are of course always interesting to observe, but we can actually provide or produce these positive sample rates to see like the prevalence of each pathogen in a given period of time. On county level, as I said, but there is more to it. As was the case for the antimicrobial dashboard, you can select per country. You can select which time frame you would be interested in most, but you can also select which kind of types, production types or diagnostic texts were being used. Not only that, but if you look for different countries, it can become quite clear what are the most common methods of actually sampling animals, what kind of diagnostic tests are mostly used, and does that influence how we look at disease in a different country. To do that, I will show a number of simple examples in the next few slides. But first, maybe what we have up until now, as I said, now we also have data from 2025, so there are even more samples, but as you can see, there are quite a lot of analysis included in this. What we found is that still necropsies are the most commonly sent in sample type. then nasal swabs, then the lavages, and then the transtracheal washes. If we look at production type, overall beef was mostly sampled, then dairy, and then veal calves were included in our data sets that we got. And then PCR is the most popular or most prevalent diagnostic technique that is used, then culture, and then maybe because it's more recent or still young, the nanopore sequencing. In general, using that information, we actually got now for these different counts, for each pathogen we get counts, meaning how many samples were positive, and of course based on that we can determine a positive sample rate. If we look at the sample rates, this is for all 4 countries combined, they are very much in line with what we expect or what we saw in the Flemish barometer that was already developed by one of the contributing labs. We can see that those are actually overall quite similar, with very high prevalences of Pasteurella miltosa, which is not illogical. But for example, the bovine coronavirus with a prevalence of or a positive sample rate of almost 20%, which is actually much higher than what is previously believed. Of course, this is an overall view. Using the data, we can look at it from multiple different perspectives. Here, as I said, we can get counts, positive sample counts, meaning that how many samples were actually positive in that area. This is the one on the left, which is logical. We kind of see a seasonal pattern within the winter, more samples being sent in and testing positive, but it also translated in a higher positive sample rate or a higher positive percentage in that area. So we do see a seasonal pattern if we look at these diseases, which is something we know, but it's also nice to see that if you combine this data from these different labs, that you can actually visualize it. As said, this is all of the pathogens combined, but using our tools, our selection tools, we can actually get a look at different pathogens in different countries more in depth. For example, here, if you only look at BRSV, a virus, which we already assumed or kind of know that it's seasonal, if you only look at that pathogen, then we see that it's very much more seasonal than when we include all pathogens. Here, this is the data from 2016 to 2023, and every winter month you can see an increased peak, which is not always exactly on the same time, but still it's very predictable how those curves will run. That's one thing. But then, for example, if we look at Mycoplasma bovis, a disease or an infection which we know is more endemic. It can cause outbreaks, but it's much more endemically present throughout the year, deserving our attention. You can see that those seasonal patterns are much less prevalent. But what is the difference? If you look at these different pathogens, also the approach can be different. The RSV viruses, we expect them to be there in winter, but still, yeah, that's now what we're currently exploring, is whether we can use this historical data to actually develop like epidemic thresholds. When should an alarm bell ring? And can we predict what those thresholds will be? When the peak will come, at what month or even in what week the peak of the RSV is expected, and how long that epidemic will last for each year. So having that information, you can still maybe in time alert farmers and veterinarians that it's not too late to start vaccinating. If you can detect it early enough, then this might also be an opportunity to increase our biosecurity and increase our vaccination status of these animals and increase protection. On the other hand, Mycoplasma bovis, as an example, as said, more endemic, but if you look at this at country level, you see that there is a large difference. With some provinces only having 8%, with the other ones 63%. So in that sense, keeping an eye out on this system can also help when you're aiming to purchase cattle, larger groups of cattle, so you're not indulging or buying from high-risk areas at that time. Of course, research shows that these high prevalences can vary throughout time. So in that sense, that's also what we're trying to do, is further updating it so we have more continuous data flow. Another small example is, just to make sure how this data can show that it's really important to know what you're looking at when interpreting it on a country level. When we looked at Pasteurella miltosa and Histophilus, we actually noticed that in Belgium there appeared to be a much higher prevalence. At first glance, that's a bit weird, because our systems are not that much different, and we're quite neighboring countries. But if you look more in depth, then you could actually see that in Belgium, there were a lot more PCR testing done than, for example, in the Netherlands. If you look at PCR, then Belgium is more prevalent, but if you only look at culture, then we actually saw a higher prevalence of both pathogens in the Netherlands. So just I wanted to address this because it's very important that if you want to look at these diseases on European level or larger level, we have to make sure that we're comparing apples to apples and pears to pears. So we're not misjudging the information that we get, which also is a very helpful insight that the barometer delivered. Then, as a last example, a bit from the similar type, if we look at Mycoplasma bovis, of course, it's a bit a work that I work on quite often. We actually saw that if you look at the positive sample rate in, for example, the Netherlands, it's only 11%, where it's almost 3 times higher when you look at France. So at first glance, if you would interpret this on a European level, it would be very, wrong in that sense to assume that the prevalence of M. bovis is much higher in France compared to for example, the Netherlands. Because if you take a deeper look at what production times were mostly included, sent in by the labs, then we saw that in France, the veal industry was much more represented instead of the dairy or the beef industry. And that's what we know from the veal industry, is that because they commingle all these calls from all these different farms, they actually deal with M. bovis in almost every round, or actually every round. So again, to emphasize that these tools can really be used to not only help you predict outbreaks or purchase examination, that kind of stuff, but also can help prevent misjudging of or misaligning of interpretation of this data on a countrywide level. So in that sense, that's what we're working with. Here is a QR code to our website. I would highly suggest that you take a look, play around with it. It's nice to do the different pathogens, the different production types. Yeah, once you start, it's hard to stop looking for patterns and exploring with it. So I like it a lot. Also, that's for veterinarians and farmers. For labs and institutions willing to contribute, we also have tutorials to show you how we format the data, how it is possible to contribute. And everything, of course, is open source to see how that information is being handled. For the future, next steps, of course, we currently have 4 countries. We are in contact with some other labs to include it. It is always nice to include more labs. The more data from different countries we have, the better our surveillance system or monitor system can work. And of course, as I said in the beginning, it is quite a hassle to include all this data and get them in the right format. But within the project, we worked out a system where we can actually automate that system, and data gets, for example, weekly updates in quite an automatic fashion. The early warning component is what we are working on a research perspective. And then, of course, as a final thing, thanks to Charlotte as well for all the help and organizing the surveys that were being done. We are constantly updating our tools based on feedback, on user feedback. So in any case, if you are wondering or going to the website or using the tool and you find any things that are not working, errors or any feedback, always feel free to contact us so we can also include that in our improvement of the tool. So with that was actually it for me. If there are any questions, then I would be glad to answer them. Thank you.
Thank you, Stan. Thank you, Charlotte. We've got 3 minutes, so if anybody's got a burning question to raise, John, go ahead, please. Yeah.
That's very, very cool. I think that's a great app, and I think you've got lots of really nice data. One thing I wanted to know is about whether you see or can see in that data multiple pathogens on one farm or in one incidence of disease, because I'm sure that's happening. Have you tried, or can you do that?
That's a good remark. I think you mean that, for example, on one farm you can have co-infections. So you
That's
have
right.
multiple pathogens
Yeah.
circulating at one time. That is very important to know on farm level, of course. But the way that the data is presented now, yeah, it is basically split up. So each sample, for example, if a sample is taken from a farm and there is a PCR test done on 7 pathogens, then it's actually split up to have those prevalences separately. But that's actually something interesting to look into as well. But it could provide some difficulties in visualizing it on a dashboard level.
Yeah. We talk about it a lot in practice, but we don't really measure it. That data set would be a good opportunity to see how common those multiple infections are in one epidemic. Thank you. It was a great presentation.
Okay, I'm afraid I'm going to have to draw this to a close. Stan, Charlotte, thank you so much for the useful presentations, and please take note of the fact that this dashboard is available. We will be, I think, circulating the information after this talk. I think, Margarita, you're going to be doing that, so look forward to further interactions. Margarita, is there a date set for the next seminar already on the topic? I didn't ask you this beforehand. Maybe you just want to say that as we close.
Yes, thanks, Jonathan. We don't have the exact date yet, but we will announce it. Thank you.
Okay, great. Well, thanks for some great talks today, and we look forward to sharing with you more information soon. Yeah. Have a good day, everybody. Yeah. Thank you.
Bye, everyone. Thanks.
Bye. Thank you.
All right. Thank you.
Well done, Margarita. Thank you.
No, thank you as always.
Margarita, just a question. Jonathan posed me a question like what I've seen in the other webinars, that we have a lot of people from DECIDE or GBADs in the